Kia ora koutou, ko Douglas Walker, toko ingoa. Here today at Paraparaumu College with Shane Omani. Shane's a physics teacher here and he's done some amazing work with compressed air rocket launchers. And so Shane, I'll hand over to you to talk us through the amazing designs you've got.
Right. These designs are a accumulation of ideas that have been out in the science community for a number of years. I think it was first I became aware of it from a science conference in the South Island. This was originally built from PVC. Some of my colleagues got a bit worried about it, so we've moved to galvanised pipe. This is available from standard lengths from Bunnings, just put together then with Teflon tape to get an airtight seal. This cap required a hole drilled in it and a standard Schroeder valve inserted into there with some epoxy. The launch method, I looked at using a hand valve, but decided maybe a solenoid might be safer and cooler. And this is a irrigation solenoid valve purchased from a firm, I think in Tauranga, and somewhere between $50 and $100 for the solenoid. The reduction valves in PVC came from our standard plumbing supply merchants. It was decided to use a 22mm pipe as our size, and we construct to make a firmly fitting rocket that just slides on and off the 22mm pipe. Again, the solenoid is powered from a 12 volt batteries, and the setup is a safety on switch followed by a launch button. This is essentially used for 9, 10, 11, 12, where you're interested in up and down, flight time. If you have the flight time, you can do a lot of calculations. Over here, we have an identical setup, only this is put at an angle of 45 degrees, and this is used for level 2 physics projectile experiments.
Fantastic, thank you Shane. With the, sometimes my students ask if they can catch the rockets. I'm guessing those come down at reasonable velocity, and what do you instruct the students to keep the area clear?
I instruct to keep it clear. I tend to arrange things so the observers are upwind, and I say, well, as to catching, let's launch the first one, and you make a decision after that.
Brilliant.
When they see it come down, there's usually, no, I think we'll leave this.
Yeah. Good stuff. Would you like to talk us through the design of the rockets then? This looks really cool, and I think you've said that you'll share with us the PDF, and so that'll be in the description.
Yes. Yep. The PDF, the template is one sheet of 160 gram card available from Stationery Warehouse. These ones. What makes construction easier is this mandrel arrangement. Piece of pipe, the same as the launch pipe, cut to the length of an A4 sheet and stopped at one end to make things easier. The standard dowel has been wrapped so it fits, and 120 degrees has been marked off to make lining up the fins at the right place easier.
And you particularly like this template because it fit the whole rocket onto one sheet of A4?
One sheet of A4, yeah, the whole. Okay.
And then once the students have made the rocket, there's a few other things you add?
In
terms of...
Oh, right, making it. Okay, the construction is wrap pieces everywhere. First is to wrap the tube around the tape, and then the card around the tube, my apologies, and tape it in various places. I then usually finish by making a full wrap, full strip down there to...
So students coat the whole rocket in tape?
Then I suppose I should say I use 3 tapes in this construction. Scotch tape, heavy duty packing tape, and double-sided sellotape. As well, the other is plasticine. I prefer it to Play-Doh, and this is loaded into the nose cone and the plasticine's available from Spotlight.
That looks fantastic.
Okay,
so I think you're not. You've got the fins on there. Shall we
Yes.
have a quick talk about the propellant?
Right, and the propellant is compressed air.
Would you like us to talk us through the rationale behind the?
Right.
Because you're not using. There's other ways of doing this, but you've chosen this for a reason.
We got lazy. Foot pumps are perfectly adequate or a hand pump, anything that will get you up to at least 60 psi. And I decided to go with a scuba bottle.
Yep.
To make it a bit quicker and just easier. So
you've got your pressure gauge on there.
yes, that's on the low pressure side of a scuba bottle or a scuba regulator. It replaces the mouthpiece.
Yep.
So that is normally limited to, from memory, about 180 psi.
Okay.
So that's an immediate safety reduction. It's not the 2000 psi of the bottle.
I'd be interested to know what sort of PSI we can manage in these contraptions. We've never gone beyond about 120.
Yeah, the pipe itself, I think, is rated to about 30,000 psi.
Oh, fantastic!
Yeah, so there's a slight safety margin.
And you've moved away from hand pumps, foot pumps. What are the advantages of this over an air compressor?
A portability. We put ours out in the middle of the field, so getting an extension cord that far has problems. This just can be wheeled anywhere, anytime.
Fantastic, and I suppose it's a bit less noisy as well, isn't it?
Yes, yeah.
In terms of how many launches you'd get out of a tank?
I don't know, because I haven't emptied the first bottle yet, and we're still 2000 psi.
Wow, that's incredible.
Well, yeah.
And so this was just filled up at the local dive shop?
Yes, which unfortunately is getting further and further away.
Okay. That sounds right. How long have you been running it, and with roughly how many classes?
So far that's run with about 5 classes for 12 months. But there's going to be a cost because that bottle is going to have to be retested next time I take it in. So there's not just the fill cost, there's also the scuba bottle requirements. So this is most likely a luxury rather than an essential part. The hand pump will work perfectly well. And,
Brilliant. Thank you so much, Shane. That's awesome work.
Right.
Really appreciate you sharing that with us. Thank you.
I have no idea where that went. I'm worried that your neighbours might be...
Oh, I think I see it.